Welcome everybody, and welcome to NetPedia's Day-06 classes. This is Cisco and sysadmin 20301 customized course with Chapter 1 Introductions to Network Basic and Devices. So far, we are still learning the same chapter, what we was learning a few weeks ago. And this chapter is again, describing about how networking has been evolved and how networking still evolving a day by day. So still we are at the same page. Any confusion so far in the previous classes so far? Anybody has any questions or any queries about to be answered? Anybody from you? Have you watched my last class? Like, have you been in the class last time? Hello? Is anybody? Yes, no? Is any questions to be answered now for the last previous classes? Sorry, you were in the last class, I know. No need to be answered for the last classes? Okay, I would say you guys know. Yeah, okay, great. Thank you, Mubarak. Nice to know that you guys are still learning about everything that I've been teaching the last few classes, and you were in the class. Nice. So let's talk about what was in the last class that I taught. What was that? Is anybody can say, like, what was about the last class, like what we actually learned in the last class? What type of termination was the one what I taught you in last class? What was that? Let us know in the chat, like what was actual termination that we did in last class. It was a small video which showing about how a termination happened and how you terminate a jack from 365. No? Okay. What's that? All right. Okay, let's go to next chapter. Okay. Sorry, somebody wants to say something? Go ahead. No problem. Okay, let's go to the next chapter, which is more to the depth of physical connections. We're still learning, how a network actually operates from a deep layer, from the top or down layer to like layer 1 to layer 7. So I have not taught you yet OSI model yet, but my planning is to give you OSI model once I cover all these aspects of physical layer. Then I want to give you a deep down detail of with the animations, how a layer 1 to layer 7 works. But before that, I wanted to talk to you about, okay, how a full physical layer works, like how a networking connects. So you can, when you go to OSI layer, so you don't get confused how these things working. So let's make it very more comprehensive for everybody. And let's go to the next chapter. Again, Cisco and Cisco Admin 20301, Chapter 1, Introductions to Network Basics, Devices, Day 6. So we're going to learn today 802.3 networking standards. This is all approximate. Everybody should aware if it's not. So let me explain you about this one. So this is standards are completely from ITF, or you can say IEEE, and International Engineering Task Force, Engineering Engagement. So this specifically standards are comprehensive. These are standards. It's just a standard. It doesn't mean to be this is actually physically available. It's just a standards. It's just a rules and regulation. What you can say, just a rules and regulations. That how a network works, how a physical layer works. So these are rules and regulations. So when we were in the networking, when we started the networking, right? Whenever you start a new company, right, or whenever you start anything, right, new technology. So there must be rules or regulations are not really that comprehensive in the starting. Let's say you start a new business, right? So first your priority would be to run a business somehow, right? Then once a business got established, then you start adding some rules, because you want to keep autonomy, that you want to make sure that business is automated, so that everybody following the same rules, right? So that's why we have to have some standards. And this is a 802.3 standard, which mainly, this is a mainstream for physical connections and data link layer, sorry. And the layer number 2, which is data link layer. Hopefully everybody aware of data link layer. We have been almost explained in last couple of chapters where I was talking about switches and hub operations, how switch and hub works. So there was a one MAC address, right? MAC address was there, which is most probably a data link layer, which is mostly a data link layer. We call it, data link layer. So everybody maybe remember it. If you don't, then you go back to the same video and watch it again and see maybe, and you can ask me the question in the chat too, hey, why is it, if you have any confusion. So Ethernet with 802.3 standard. Ethernet 802.3 standard, wired local LAN standard, and that defines physical and data link of Ethernet protocol. It is a part of IEEE 802.0 set of networking standard, which cover various aspects of LAN and other networking technologies. Ethernet 802.3 specify the rules and conventions for transmitting data packets over a shared switch medium using a variety of physical layer technologies, right? Physical layer technologies such as switches, cable, and you have hub. Then you have a PC or like servers. So these are all run under 802.3, all under 802.3. Even if you terminate a cable, when you terminate a cable, right? Like in the last chapter we did it, last class we did it, terminate a cable would fall under what? 802.3. All are 802.3. Understood? Any questions so far with anybody? If need to be queried. Okay, let me go to the move next. Then we have a physical layer variations, right? So Ethernet 802.3 encompass, something is wrong here. Did somebody took permission to be coming? Barak, have you been tried to alternate it?
Sorry, it was a mistake. Sorry.
Okay, no problem. Do not alternate, buddy. Fine. Okay, can you clean? Okay, I'll clean it. Can you clean it by yourself, please? Maybe I would not be. Try. Again, you can start. Thank you. Okay, let's transmitting. So we have a physical layer variations, right? Ethernet 802.3 encompasses various physical layer options, including twisted pair that we learned last class, and in a couple of classes actually. Twisted pair copper cables, fiber optic cables, and coaxial cables. We will be learning in the next couple of classes. Each of these physical layer technologies has its own standards and specification, but they follow the common 802.3 format and data link layer protocol. So, Ethernet cable, which is a copper cable that last time we learned, Ethernet cable, right? Which has some sort of termination we did it last time. So Ethernet and optical and coax, they work on different media. They are pretty different media. They all have, let's say this one works on what? Copper cable. It's a complete copper cable with 8 pin outs. Optical has what? It's a light. It works on the light stream, right? A laser light stream, which comes from which go from one end to other end. And then a coax cable is a one cable with the RF jacket, and that's a different cable. So they work on pretty different thing, but they follow the same rules. Follow the same rule for transmitting packet. for transmitting packet and receiving packet, like share the data. They follow the same rules. Despite of there being different cables and different type of media formation, still they use what? Same follow rule. They use the same rules. So there is a less chances of that's the best thing to have. When you have, so this is always have to better to much better than any other protocol. They're much better than any other protocol, just because they have a simple autonomy following the rules. Now let's go to the next. So the standard, then we have a frame format. We just talk about how the physical way. So we have frame format, that how a switch, when you have switch here and a computer here, right, a PC, and then we have another switch here, and then I have a PC here, how this frame from here to here travels. These are all our A2.3s, A2.3, not the routers, not the layer 3, only layer 2, not layer 3, not only layer 2. So it means layer 2 what has the frame. I'll talk about the frame again in the USA model, but layer 2, all kind of frames, it has to follow the same rules. Despite, doesn't matter which type of media you're using. Are you using here fiber? Are you using here coax cable? Are you using here copper Ethernet cable? They have to follow the same rule for frame, how the frame will travel and how you will understood that frame, and how you will transmit those packets. Oh, sorry, transmit those frames. So is always what? How we follow this standard. This is the standard that we have to follow. Then we have a preamble. Preamble means a sequence of alternating 1S and 0S that helps receive synchronizing. We will talk about more in the detail in the next upcoming topics. But preamble, it means when a switch and a PC connect here, whenever they're sending a traffic here, right? Whenever they're sending a traffic. So what happened? They always send a full frames information that what I have, how much I need to send you, and switch already know that how much I need to receive. So there is no confusion. Sometimes let's say you have a 1400 frames here, right? And you did not tell, okay, I'm sending 1400 frames. You didn't tell the switch. So switch maybe end the session and this connection somewhere at 1300. So you will have a less data, right? You may have corrupt data. So you have to know already. So it will always tell, okay, how many frames I'm sending you right now? What would be inside bits? How many bits would be inside in each frame? Everything will be pre-calculated before happening anything on the network. So it's pre-calculated. Always calculate and send to the frame, and both ways. Switch will tell to PC and PC will tell to switch. They will always know that before. Early hand, they know, okay, I have this much, so I will receive it. So there is no corruption data and anything, right? Understood? Any questions so far? You can put on the chat too. Then we have a start frame delimiter, which is the same as the mark in the end of the preamble and the start of the frame, which is the same thing. Then destination and source MAC address, we learned about it in last class too. What is a destination and source MAC address? Then we have Ethernet frames, include the MAC media access control address of both sender and the recipient device. That's always a follow the standard of what? This is the standard of A2.3. Then we have a ether type or length. Specify either the type of data in the frame or the length of the frame. Is always the length and frame is there. What is the length would be what each frame is always be in the written before. They have to written in the frame, and the pre-frame will tell everybody. Preamble frame will tell switch, okay, this much frame, this many frames will be coming into your network, so make sure allow it. Then we have data. The actual payload or data being transmitted is always being there, payload. Then frame check with sequence, a sequence, if any error, let's say if you send a data before and afterwards, let's say you tell them 1400, so you count 1000 to 100,000 frames, you counted it, right? You counted first, and you send to the switch here. like frame. Let's say you switch 500 frame. Then you switch 504th frame. So you missed 1, 2, 500, 1, 2, 3, you missed it, right? But then we have 802.3 standards data link layer, which is again, it's a MAC address and source and destination, operates at the data link layer of the OSI model. It provides addressing and access control mechanism, ensuring that data packets are transmitting only to their intended recipients, and the multiple devices can share the same physical meeting without causing data collision. So that's even the CSMA and CSCD, which is just a basic overview, is being fall under what? A2.3. So they all fall under what? A2.3. Even the termination from cabling, sending frames and receiving frame, everything fall under what? And then CSMA CD Ethernet originally used a protocol for called carrier sense multiple access with collision detection to manage access to shared network medium. CSMA CD enabled device to listen for activity on the network, wait for a quiet period, and then transmit their data if a collision occurred. Two devices transmitting at the same time. They could back off and retry at random intervals. So, you know, when you used to have a hub, we learned about in the hub what? The hub we learned about what? We learned about when it send a packet, it's sent to everybody, right? Everybody. So there's a duplex, half and full. Means, you know, you can listen and sending the same time, but only can switch can do, but hub cannot do. For so hub has some sort of, you know, system inside. Okay, when any computer is sending a data from here, any computer is sending a data, so hub will not send to the same carrier sense. Hub will never send to the same. Hub will never send to the same until it's receiving. So it's kind of a you know, very great protocol that is being used, and it's a standard of 802.3 that it has to wait on the same cable to receive and transmit data, which is a bad practice for sure. That's why the new physical switches came, which has a more capability of sending a full duplex. Like you can receive and you can listen the data on the same port, so you have more cables. And anyway, we can go into the detail. For sure, you will learn in the details soon. It's just an overview right now. It's just not really a very deep depth of what we are doing right now. But in practically, we will see everything in the future classes. Then we have a switched Ethernet with the advent of Ethernet switches, which create dedicated point-to-point connection between devices. The need of CSMA has largely disappeared in modern Ethernet networks. Instead, switch ports Ethernet allow device to communicate without the risk of collision, improving network efficiency and performance. So CSMA CD has been now there is a very less chance that you will see CSMA CD and brought these things. It's a very less chance you will see that in the future as well, because you know switches works on intended ports. So like, so what happened? The switch, when you have a switch, you always, what you do, switch only send to the packet which the connected with the MAC address. So if there is a one PC1, if there is a PC2, if there is a PC3, and if there is a PC4. So when you receive in packet here, so what happened is this port will here receive the packet, and it only send to the PC's MAC address. Only sent to the PC's MAC address. So in that case, what happened? You know, you'll have a less chances of CSMA CD. Like there is a less, nobody broadcasting for the whole packet. So it means CSMA CD is very less now. You know, you would see in the switches, but only in the hub for sure. All right, let's go to the next. So speed and variations. So, you know, you have heard about, okay, how much internet speed you have, 1 gig internet speed, 100 MB internet gig speed. So these speeds and variations are fall under what? They are same fall under 802.3 standard. So you may have a cable of saying, okay, Cat 5e, which is being used now still nowadays, Cat 6, 6a, and 7. They have a different speed. It works on 100 MB and to 1 gig. And this is only primarily on 1 GB speed. This is on 1 GB to 10 GB, depends on the very length. And 7 is only on 10 GB. So, you know, so these variations of speed and how these speeds will calculate the data and everything, that's all fall under what? 802.3 standard. All fall under 802.3 standards. And then we have Ethernet 802.3, the foundation of wired networking has been numerous advancements. Adaptation to meet the growing demands of modern network. It means a widely used and essential technology connecting computer devices and networking equipment with a local area network. So you can see that. You would see in the further classes, like how further topics too, how this is being advancement for our networking. If there was no 802.3, what would happen? Okay, so now we're gonna learn about how RJ45 female jack types and patch panel description. What is RJ45 female jack? In the last class we terminated that jack. If you go to the last video of day 4, so you would see we have terminated one jack, or was a where it has a cable that we cut it from here, and then there was a jack, and you terminate and you punch down, or you can do a lot of different ways to terminate a jack. So we did in the last class. If you go to the last video, you would have know much better. Okay, what we have done in the last class. Okay, but still, I'll explain in this class too. A female RJ45, also known as RJ45 socket or port, we call it socket or port, is a common networking interface connector used in Ethernet networking. It is a counterpart of the male. So it is the opposite of the male. So there is a male adapter. So there's a female adapter. So there's a kind of two adapters. So if you have a female, so you would need a male as well. Same as your home, when you look at your home socket. So when you connect your iPhone charger or something, so iPhone charger has what? iPhone charger has a male adapters, right? And then you have on the wall, there is a female adapter, which you insert in that those ports, and you get electricity. Same as networking. So in the networking, you have this female ports, right? And you have a male jacks too, these cables, right? And when you insert these into the female ports, what happened? You get an internet. Same as pretty normal, commonly what normally what we use it. So, and there's two kind of thing, if you have a female adapter, so wherever you keep it in the networking, so we call it either wall plates or patch panel. We call those things patch panels. And then we have connector shapes. So you can have a female RJ45, a lot of shapes, right? Rectangular, and 8 metal pins arranged in 2 rows of 4. These pins are used to transmit and receive and data signals, right? And then the housing jacks are typically made of plastic and designed to accept a male RJ45 plug that I explained earlier too. May have tabs or locking mechanism to secure the plug. So it should have a lock so the cable doesn't come out, right, easily. Then we have a color coding. So the jack may have color-coded ports or wiring labels to indicate proper order for connecting Ethernet. So it could be T568A or T568B. These are wiring standards, and I explain in the next chapter. And number of ports. Female RJ45 can have a multiple ports depending on their intended use. Single port jacks are available too, or you can go up to 48 ports. Like in the single panel, you will see 48 ports. Mounting, they can be surface mounted, panel mounted, or snap-in mounted, or depending on the application, like you can do anywhere. So it depends on what you need, but there can be. So in the next one, you would see what it look like. Yeah, so these are female jacks. These are the female jacks. So see there is an option to insert your patch cables, right? So these are jacks. These are female jacks. These are female. This is the female jack 2. This is the female jack 2. This is 2, and these are all our female jack. This is just as if you don't have a patch panel, so you can use just one. So these are female adapter. I just kept it, make sure you understand. So these are female adapters. So one male to male if you have, so you can insert this one to have a connectivity between 2 male cables. And that's 8 points. So you have 1, 2, 3, 4 on this side, 5, 6, 7, 8. So there is a color coding here: green, orange, orange, and white, green. Same on the other side would be have blue, or white, blue, and white, brown, and white, white, brown, and white, blue, and solid blue, solid brown. Sorry, yeah, solid brown too. So on the other side, so there will be 8 colors total, 8 wires. So you have 1, 2, 3, 4, 5, 6, 7, 8. So it means you have to have 8 wires in the Ethernet cable to terminate a jack. And same is here. So this is a cover on the top. This is same as that, but just a cover on the top. And then you have a chip. This was chip 1, which is mostly in the computer itself, but you can have for some other use too. There are some other diode use as well. I'll explain you in the, if I got a chance, I'll explain you where the diode use works. And these are the tap fix ones. If you want to buy just 4, and you can terminate these ones. These are white, so they could come on different colors: blue, white, black, any kind of color you can find on these ones. It doesn't need to be necessary the color you're showing, only you get it, but you can have white. So see here, a cable coming from here, and it's terminated. It's terminated in the last time you did it, and you insert that jack here. You insert the jack here, right? You insert the jack here. So this is the female jack now. So you can go up to as many jack. So what is the benefit here? Now you can put the labels here, label 1, 2, 3, or 4, 5, or you can put the label, printer labels, okay, LAN label, or office number. So you can put different kind of labels here on the top here. And at the back on the cable, you can label too as well. Like when you're running a cable, so you need to put a label as well here as well, or put a small numbers, so you understand which cable coming from where, which office, right? Okay. Hopefully you understand that. Any questions so far? Vikas, anybody? Mubarak, Isabel? No questions? So these are the jacks, which is inserted after the termination. And these are the wall plates. That's what you see in your home or in the offices. So these cables all the way go at the back go here. And you put it here. So you can put a computer here, and computer here, but these are one single wire connected all the way. So both ends. These are what? Both ends cables. Hopefully you understand this picture and a bit a clear concept of this. Now you can unmute self too if you want to ask something. I'm given the option. Okay, and this is the RJ45 male side. We learned about the last was the female side. Now we have the male side. So male side is same as that. It's known as what? RJ45 plug or connector, right? You have iPhone charger, right? You have iPhone charger, right? iPhone charger, you want to connect it to what? To the wall socket. That's a female socket. Same as this adapter, you have RJ45 plug. That's intended for what? Wiring. For electricity, this is intended for what? Internet or connection between your devices. Is a common component used in Ethernet networking. It is dependent being inserted into female RJ45, creating a connection for transmitting data signal over Ethernet cables. Here is a description of a male RJ45 jack that you can, for presentation. And you can do the connector shape. The male RJ45 is a small rectangular connector with 8 metal pins, same as the RJ female adapter. These pins are designated to align with make contact with the corresponding pin in the male. I'll show you what the pin looks like. And then you have a wiring configuration that are 8 pins inside, and wired specific standard. Either you can go 6/8A or 6/8B. So same as female follow the same standard A or B. Then you can have the male as well. Male follow the same standard A or B. And 568, sorry, T568 A or B, or T568 A or B. Male and female both follow the same standard of 8.2.3. In order in which individuals wire Ethernet should be connected, ensuring proper data transmission. Strain relief, maybe have a built-in strain relief mechanism which secures and prevents it being accidentally pulled out a connector. So it has a mechanism inside that, if you punch down a cracked connector, so the cable will not come out easily. Even accidentally, if you pull a cable or you step down on the, if you strip down a cable, so it doesn't come out. It's more secure, right? Then you have a latch or clip. It may have a latch or clip inside, so it doesn't, it doesn't come out, right? I'll show you what that clip look like. So it insert into a female adapter. So when you plug into the, in a female adapter, so when you click on it, when you plug it back and, when you click on that, so it lock it by itself. So when you plug it, the mechanism ensures a snug fit, prevents and connect from disconnect unintentionally. Compatibility are designed to be compatible with various Ethernet cable types, Cat 5e, Cat 6A, 7, depending on the specific connector. So every cable have a different connector, right? For female and male both. So if it's a male, if it's a female 6, right? If you want to have a one cable to have a female connector, right? So depend on your cable, Cat 5e, 6, 6A, and 7. All different have a different connectors. Depends on your side, depends on need, you will order those kind of. Same as an instance for RJ45 as well. So you can have a Cat 6A patch code, Cat 6A, or Cat 6, Cat 5e. So it depends on, you can order those kind of connectors. So make sure you always compatible with these things. Make sure you have a compatibility. Usage, RJ45 and device Ethernet cable, they are inserted into female RJ45 jacks on networking devices such as computer, router, switches, and network panels. Color coding, yeah, same, T568A or B. So now go to the next. Now these are how it look like, right? These are what RJ45 may look like. So you just saw the female, right? Can you say in the chat yes or no? Do you remember how a female look like? Yes, no? So in the female, there was a kind of female adapter, and you can plug into this one, right? So these can plug into, and the same here. These are the more like robust. The cable has the same adapter here, like same connector, but it's have a boot as well. But this called what, patch cord. We call it what, patch cord. So this become patch cord. So you have both sides. The small one, that's a little bigger. That's just a basic, right? So you have both connector on both sides. One connector on this side, one connector on this side, and make sure these connectors follow the standard what you need to have. When you terminate those standards, make sure these follow the standards. When you see here the cable types here, green, orange, this is a type B that somebody terminated. You would see this, color codings here, and these are the pinouts that I showed in the last PPT. That pinouts, we call it what, pinout. And when you terminate these guys, so it cut it, and you have a solid this kind of cable inserted in. This is a jacked cable, a completely jacked cable. This is a red color, that's a blue, and and that's a or a yellow, and that's a blue. So different type of. So it has a depend on the speed, right? Depends on the speed you will order. Depend on the speed and type of cable. Speed of cable you will. Okay. Great. Okay, so depends on the speed, right? Depends on the speed and cable type you will order. Same for female and this is true for what, female and male. Even the female adapter here, right? So you will order the same kind of thing, female and male. So let's say if it's a Cat 6, right, cable, Cat 6A, so Cat 7. So you must know which cable has compatibility of these adapters. So maybe this adapter is only good for Cat 5e. So it doesn't matter which cable you are using, so you will not get that speed. So make sure whatever even for the female as well. So make sure when you female have this cable, when you have female, make sure that you have this compatibility. So could be a Cat 6 and 7 has a different kind of switches, different kind of ports. Let me show you actually. 7. So here is the thing. See here. See here. When you go here, see here, it's saying cat 6, right? What is it? Cat 7. 5 pieces mean like 5 pieces in the quantity, but this is a cat 7. This is a different C, it's a steel one. Then it's a RJ45 for cat 6. Cat 6. See, it's a cat 7. So for male, you have cat 7. See this strong, robust, very. So cat 7. So same as that. See, this is the cat 7. It's a steel one here. The one I showed you in this one, not a steel, right? So see, that's the thing too. So you have make sure this, you have compatibility of a cable too, like for cat 7 and cat 5 and cat 6. Make sure. And then we can learn for more. We can learn for male, female as well. See here, you would see, you can show you pictures maybe. Yeah, see here, you would see a big difference actually. So see here. See here. This is how it look like, different kind of thing. This is kind of different kind of, see here, a steel one. And this one, see, this is pretty empty. There is no steel, nothing like, there is no aluminum or nothing like in the top. It's just a pins here. Even though pins here, but on there is a buffer, a very high strong buffer too. On this one too, see, different kind of thing, right? So this is what, and this one too, this is a RJ7 for Cat 7 cable. So you must know a Cat 6 and this is a cable type. So Cat 6 is just normal cable twisted, and Cat 7 has a buffer as well, like a shield buffer on the top. And that's being into this connect to this one, make sure you have a full ground. And that's for Cat 8. If you have a Cat 8 Ethernet, so this is for Cat 8. Very strong. See how strong it looks like. So depend on the cables type, you need to order these kind of things. Understood? And clear everything, buddy? For everybody? Okay. So let's go to class. Go to the next slide. Any questions so far? Anybody? No? Okay. Then we have a base T. Base T, even the fall under the same. Base T fall under what? It's on same. Same A2.3 standard. This is fall under what? Same standard. So Ethernet is a family of specification that governs a few different things. It covers all the different wiring specification. 10 base T, 100 base T, 1000 base T, etc. It describes how send bits 10 across each wire. It also determines how to interpret those base into meaningful frames. So when you actually see that, as a base T means a baseband transmission imply. This is a baseband transmission. So when you send a signals, right? When you have this from PC, you send in what? 0 and 1, right? This is how our computer understands 0, 1, 0, 1. This is the computer language. So that's when you send it. So every speed, if you're sending in 1 GB, that's a different type. When you're sending in 10 GB, so maybe switch has to understand, that frame has to understand how our traffic has to be initialized. How the computer and switch will first, whenever you connect a cable to a switch, they have some sort of PDUs going on, which is PDUs. Okay, sorry, it was an interruption. Implies that internet capacity and cable is used to transmit digital signals. The difference from broadband, where the cable's bandwidth is divided into multiple frequency channels, right? So you can have 1 GB, 100 MB, right? 10 MB on the one we used to have, 1 MB. So these are all what? These are base T standards. So speed, how your 0 and 1s will be travel over the medium. That is what a base T standard. A base and T standard. That's how it implies. T stands for a twisted pair. Like, you put in the twisted pair, the cable, twisted pair means what? Twisted pairs are just, when a cable are twisted. So to reduce the EMI, right? In the last class, you may have seen that. You reduce the EMI, electromagnetic interface. So twisted cables, and this indicates that Ethernet connection is established using twisted pair. Twisted pair consists pair of insulated copper and reduce the electromagnetic interface. Now let's discuss some common base T Ethernet. 10 base T, this mean data rate over 10 megabits per second. Over twisted cable, it was one of the earliest, quite slow by the modern standard. It was pretty slow when it came back. 100 base T, like you can go for 100 fast Ethernet we call, and fast Ethernet and 100 MB same thing. Over twisted pair, it became widely adopted in the 1990s and 2000. So we used to use this. Then 1000 base T means 1 gigabit. 1 gigabit, this standard 1 gig provides the data transmission of 1 gigabit per second over twisted pair. It is commonly used in modern networks and significantly faster than fast Ethernet for sure. Then we have a 10 GB. Now we can use 10 GB as well. So then we can use 20 GB, 40 GB, 100 GB. Even you can go for 1 terabyte. I think Huawei is doing for that, I believe. Huawei people are making 1 terabyte connection now. 1 terabyte. I think it is coming soon. But you can go up to 100 GB nowadays. We call it 100 GB. That's on fiber. I'll explain in the next classes how the fiber looks like. But right now we're not going for fiber at the moment because fiber is pretty different. Then we have a RJ45 termination male side and T568 and B. So now in the last class, we learned about how female works. Female we terminate. In this one, we will learn about how for termination male side we terminate with implies of what? T56A, 256.8A and T56.8B color wiring and code TX are in it. What does code look like? So RJ5 standard for registered jacks, standard premium like 45 specify the amount of wires in the cable, the order in which they appear and they use for is 8 PAC, like 8 pair, 8 connector. We call it 8 pair. 8 connectors, right? 8 pairs, like 8 cables, a small wires will be in, and these are 8 connectors. So we call it what? 8P, 8E, 8C. This is the specification that governs physical connector on either end of the Ethernet wire. This is what regulates are the 8 position, 8 contacts, and also define design and dimension of the clear plastic plug that terminates the cable. So this is just the termination of the cable. How it look like. So you would see some here. I told you in the last before too that there is a 8. So color would be like green, white, green, orange. Oh, sorry, yes, white, orange, solid blue, white, blue, solid orange, white or brown, and solid brown. So that's how color. And the B side, if you want to terminate a B, that's the A side. How you terminate? That's a color design for A schema. For B schema, you have white, orange, the start one, and the solid orange, then white, green, white, blue, sorry, solid blue, and then white, blue, solid green. So it just inverse, oppositely inverse of just green and brown. Green and orange got inverse here. So brown and solid brown. So these two just cable got inverse. So when you terminate a cable, right, it has to be make sure on both sides the same. So if it's an A side here, make sure you terminate A side here, not B. If it's T56.8A on this side, make sure you have T560A here. If you are sending B here, so make sure you terminate B here. Sorry. So if you're terminating cable on A on one side, make sure you same A on the other side as well. Otherwise, there will be a cross cables. Maybe your media will not work. Same as if you're terminating B on this side, make sure on other side you should have B as well. Never go A on one side and B on the other side. This will make your network completely down. Never do that. a very great practice if you really want to do that. So the good practice is that terminate base, symmetric side on the both sides, symmetric, A and A, B and B. Okay, so we can terminate cable in female and male side with two different color codings, and I explain you that, right? A and B are the common standard type. T59A is non-IETF global standard everyone use nowadays, and T56.8B known as US standard, specifically US used in USA for termination cable with specific RJ45 jacks and male jacks. So this is only used in USA. B side is only for USA. And A side is completely for globally everybody use, internationally used. And today, 256 is the mostly widely adopted standard for Ethernet cable termination in the United States, while T56 is still used in some government and international installation. The choice between the two is typically based on the local practices. You know, depends. Some country, let's say India, Africa, Australia, and some other reason maybe using A. USA right now using B. So it depends on which region you are living. So you can use any of them, but you have to same on the both side. You cannot go A this side or B other side. Make sure if you have B this side, so other side should be B as well. Do not inverse it. Clear? Any need to be explained? Anything in the chat? If yes, no. Oh, okay. The choice between the two are typically local practice. That's fine. We learned about it. Let's go to next. And we have small video as well. So why we use this standard? So when in the starting of networking, even before A2.3, when there was no standard for networking, so people used to terminate cable by themselves. Okay, put green aside, but then yellow, orange and brown. Okay, blue. So there was no standard. So what happened when you try to terminate this cable, right? When you go to job, so you would see, okay, one side is this, another side is that. So you confuse, right? Let's say you will never know, which cable. Let's say you have 1,000 of cables, right? You have 1,000 of cables, and you find which terminate you terminate on the other side and which terminate the other side. You will be confused. You will be never able to understand how to terminate the other cable because you never know which side is that. You have to put a toner. You have to put a lot of testers to test the cable, and then you identify the cable. Then you have to check on the other side, then check on the other side, just to ensure that we made a standard. Okay, at least keep it same way. Everybody will. So just to make a clear, just to make out the confusion, just to clear your doubts, what we did, we made a standard. Okay, everybody will terminate either A or either B. So you can easily troubleshoot the network. That's how it works. That's it. That's why we bring this standard. It's not really you cannot do that. You can even whatever the color you like, you can do that. You cannot do you can do anything. But just as a standard, just for people, let's say any professional person come to troubleshoot a network, make sure you follow one of the standard rules. If you don't go with rules, so your networking will be more complicated, right? And then we have a crossover cable and straight through cable. So yes, we will explain sure. What is straight through? I'll show you too in the upcoming video lecture. There is a straight through and crossover. So straight and cross-through cables are same standard of T56.8 and B. And let me see if I can go into the next and see if there are. Yeah, see here. So a straight through cable and cross cable are two different type of Ethernet cable, right? They have several different purposes, our distinct by facility specific type of connection. To understand them deeply, let's break down. Okay, so when a straight through cable works, so what happened? Let's say you're terminating in the 56.8B straight through cable, right? So this end and this end will be same on the both end, right? Right? Same on both end, right? This cable, let's say you have a jack on this side and jack on this side, right? You will terminate B this side and B this side, right? But what happened in the older switches or PC or computer in the older times, you cannot do, let's say switches are having TX, RX, like receiving on this port, right? Or receiving on this here, like TX and RX, and a switch here too, which is receiving TX and RX here. So what will happen? It will collide it when you send a frame here and when you send a frame here. What will happen? If you both are sending the frame, what will happen? You will have a collide between, like will a traffic will be collide there, right? True, right? Just to make sure more clear, what I'm gonna do, I'm gonna show you one small picture if I can find it. If I can find that. Just to clear your concept. So this is under the A2.3. We go a little far, right? I can show you. Crossovers. If I can see on this one, maybe not here. Anyway, all right. Let me find the other one I created yesterday. This one. So when we try down to twisted pair termination, so how this termination happen? Let's just see the normal termination right now. How you terminate your cable, right? You connect to the switch, right? You connect to what? You connect to the switch. And then what you have to do? So you have to, when you connect to the switch here, when you connect to the switch. So right now, whatever becomes TRX here and RX here on the port, let's say, I showed you pictures. So the first one is always TX, right? Not first one, but actually this one and 1 and 3 becomes TX, and 2 and 5 becomes what? RX automatically. So, and the same thing. So switch has to understand the same thing, which is this port of TX and which is this port of RX. So when you send it, so it will always inverse. So this is the same different devices, right? Switch and switch are two different devices. Switch and computer 2 are different devices here. So there will be no problem of sending a traffic because it will be inverse always. So what are the TX here? It will automatically become RX here. So you can send traffic. There will be no issues. There will be no collision happen here. There will be no collision. But let's say you have two switches here. You have two switches, and say if they have the same TX and RX, there's a TX and he has the same TX and RX. It has the same TX and RX. So what happened? When you send a traffic, the TX and you will send a traffic, what will happen? It will collide. It will make a lot of problem. Make a lot of problem. Just to ensure, just to clear that thing, give me a sec, sorry guys. I was just reading in. I'm sorry, Ajit, I couldn't understand your. Okay, yeah, I'll explain soon. If both sides are same arrangement of colors, but my own coloring arrangement that would affect. No, it would not affect anything. No, you can do your own coloring management, but it has to be same. So whatever the coloring management on the other side, on the A side, So whatever on the A side should be, B side should be the same, should not change anything. So both terminate ends should be the same cable. So it's kind of straight, right? So you have straight cables. You can do any color changes, but make sure you follow the international ones. Make sure you follow the international. It's much better. Same here. So that's why you need what? Crossover and straight through cables. Just because of that, because it does not understand. It used to be like before, like it's not about talking about right now, it's way before, like in 5-10 years or 10-20 years ago, there was no such thing called auto MDAX. So that's why you had a very big problem to understand the network of the transmission and receiving point. So you have to inverse it. That's why what we did, we inverse the cable. So when you have two switches connected, one switch on this side, other switch on other side, right? One switch on this side, right? Or one PC on this side. Let's say you have a PC here on the top. You have a PC here. This is a PC, two PC. These are two switch or two routers. Could be anything. Just to make sure they have a simple transmission of TX and RX. So what you made this RX, you made this TX. Inverse, you did the inverse. You did inversely. So just the same thing here now. So you have a straight through cable here. And now what you did, you make this pin go to the next pin 3 and pin 6 here. So it becomes automatically what? TX. Or RX. You terminate it on RX here. Or you can say just this becomes what? RX automatically. Receiving end. And same here. When this one sending a traffic or receiving a traffic, this RX, this is what? RX. Receiving. This is a receiving point of switch. But this cable you terminate what? Here on the point here. Right? Point here. So it becomes what? It becomes TX for switch. So now switch can send a traffic to this point because it inverts traffic, and this one can send a traffic from here because it can listen on that port or listen on that cable. Now, any confusion so far? I know this is a little confusing. Yeah, new switches would not. New switches has something called auto MDX. We're going to learn in next step, next slide maybe. So that doesn't affect anything. So that would not affect anything. Like it just do not affect anything. Just you can just literally you don't need to worry about like whatever the cable you put, it will automatically sense it and it will detect everything. So new ones are not really a problem, but only for legacy. But still, there is a lot of legacy switches are right now, right? We did not get rid of those because it's pretty expensive. So did we learn about that? Straight through and crossover cable, right? It's all clear what is straight through cable, and you just have to make sure that the pins are, you have to just inverse the pin. Okay, great, agent. So pins, you have to inverse the pin. So whatever the pins are here for TX, you have to make a receiving end. Make sure you terminate on the other end. So you just inverse it. So you have a simple, straight, streamlined network. Anyway, I'll show you the video in the next class too, how it looked like, but right now couldn't find it, what we made yesterday. Then we have a auto MDAX, right? Auto MDAX, which is a crossover detection and switch, is typically performed using a feature like called auto MDAX, auto media dependent interface crossover. Auto MDX is a technology that modern Ethernet switches to automatically detect the type of Ethernet cable connected straight through a crossover and configure the port accordingly. So what happens? You have a switch here. You have a switch here. So whatever the cable medium could be here crossover, right? Or could be here straight through. So straight through. So they automatically negotiate between each other. Okay, what cable you are using? So they send some sort of data. So they send what? Some sort of data between each other. So they send 1 to 2047 from one end, and it will send something called from 2040A to 8087. It will start some data like this sequence number on both sides and see if you receive sync number here. Like let's say you sync 1, 2, 3, 4, 5, 6, 7. You keep sending it and you receive, and you receive on 1, 2, 3, 4, like whatever the numbers you have here. If you receive at both ends, it means everything is fine. There is no need to clear, no need to switch ports, right? You don't need to do switch, don't need to do anything. But if it says, okay, I'm just receiving in 1, 3, 5, 7, all these kind of, okay, I'm not seeing all the ports. So what will it will think, okay, this is a straight through cable. Let's make it cross. So automatically straight through cable become crossover cable automatically. Automatically, you don't need to do anything. Your switch will detect it. Okay, yeah, it's working fine. So it will just make it. So now let's go ahead here. Link in the establishment. When you connect two devices, Ethernet cable, first step to establish a link. The process involves detecting the presence of cable and negotiating the parameter of connection such as speed and duplex. And then we do Ethernet ports are labeled as okay. So just as link establishment, cable type detection, auto MDX ports, and this is just happen here, duplex mode, and it will just check the speed and everything. And then it will, okay, feature found in ports are labeled as auto MDX or auto or network switches and network devices. These ports have capability to automatically configure themselves proper communication, regardless of whether the straight through cable or crossover cable. Doesn't matter what type of your cable have. You just make it. It will automatically do that by himself. Then we have auto config cable type detection. It can even detect the cable type as well, like which are Cat 7, Cat 5, everything 6 or 7. It will automatically detect it, and those cable, even the wires with the inverts, it will just configure by themselves. Once the switch determine the cable type straight through crossover, it automatically configure the port to match the cable. If a straight through cable is connected, the port may configure itself a receive port. If a crossover cable is rejected, the port configure itself as a transmit port. Pretty simple. Then we have a full duplex and speed negotiation. And in addition, the cable type detection, auto MDX ports are also negotiate other parameter like speed and like what are the speed you have, and duplex. Like you can send the traffic at the same time and you can receive the traffic at the same time. That duplex we will learn about in the future for sure. And it will communicate. And data transmission, once the link is established, all space data can be transmitted between the devices as needed. That's it. So whatever the data is there, it will automatically does by themselves. Automatically. You don't need to do anything. Okay, so we have, I think, almost covered everything that was today's topic. And I'm gonna show you some video actually. How a cable terminate. Let's make sure you guys know how. Then after we will show you what is a duplex. And so this is a twisted pair cable. This is a UTP cable that we learned in the last class. Rather than I'm gonna open in VLC. So this is a cable, right? And that's your connector. That's your connector. Make sure your connector almost, plug at the end of this cable, and make sure this jacket insert in. Make sure this jacket insert in. This jacket stays at least here until here. You can go more here as well, but there is some less gap here, so it will be very hard. So make sure your cable, your jacket must go here, must go. Otherwise, you have a problem. It can go out. even it's new switches auto embedded, but I connected these new switch through cross cable. It will understand it well. Yeah, yes, understand. Yeah, doesn't matter what cable you're using, even if it's cross or straight through, it will automatically. You don't need to do anything. You just make sure your port is enabled as an auto. So there is an option in your interface. You have to sometime enable it. Sometimes you have to enable it, auto MDX. Sometimes people disable it for some reason, but you know just to make the port really fast, because there is extra 5 to 10 seconds just to detect these links. So some people disable it, but you enable it and then you put any kind of a crossover or switch straight through cable, it will automatically detect it. Okay, so make sure you jacket go in here when you're terminating your cable, and then we can go to the next. See here, you go all the way end here, so then you can connect it. And how you terminate it, this is the unshielded twisted wire. This is shielded. We remember like what is unshielded and shielded and unshielded. And when you see inside, there is a cable, blue, white blue, solid orange, white orange. Then you have a brown, solid brown, white brown, solid green, white green. So these are the pairs inside, and it has inside what? Copper cable inside. There's a copper inside. All of these wires have a copper inside. You have a copper inside. These just are inside the copper, and you just have a color of this distinguish. Just a color. Just a distinguish a color, nothing else. So now you have a shielded one. This is a shielded one, so it may be shielded. I showed you what the shield look like. There's a shield inside, and these are the one. Then you connect it inside. Then how you connect it? See, that's the most important part. When you're terminating a cable, you must understand how you connect the cable. So this is a crimper. This is a crimper, and when you unshield a little cable from there, and you just insert in with the right jack, and you just terminate it. That's it. That's how you terminate this jack. Could be any color cable. I thought it would be more advanced inside, but no. So that's how you terminate a cable, straight patch cable, and this is a crossover cable. The same, terminate your same, but all you just do what? You just inverse your colors. So see here, twisted pair cable. This is A. This is B. That's it. And then you convert in A and B, whatever you want to make. You can make it like TX and RX for crossover, and keep it a straightforward, straight cable. This is just a basic of A2.3 standard. You can go more deeper when you learn in CCNP. You will learn more into more depth how 1010S works. I'll show you that too. It's a straight through cable, and so when you want to connect to the straight through cable, so straight through cables mainly used between different devices. Let's say, see, this is a different device. This is a different device, right? So when you have a different device, so then you can have a straight through cable between and a straight cable. But when these kind of devices, same kind of devices, you need a crossover cable. Simple as that. Nothing more fancy on this. See here, so it connects to the similar, that's a dissimilar device together. So you can have the same kind of similar across straight through cable for similar, so this cable can be used for modem, or you can directly connect it to, because these are connected with the dissimilar devices, unlike devices you can see. These are not same devices. These are 3 different devices, and you're connecting to one. So you can do whatever you want to do. All right. So then you have twisted pair, and the same with the twisted pair. You have B. Now you have a crossover cable, and crossover cable when both cable are wired using the 2 different standards, and crossover cable are 2 similar devices. So when you want to connect to two similar devices, you will use what? Crossover cable. Pretty simple. Nothing very fancy on this. And same as here, like switch want to connect to two switches want to connect to each other. So you can have crossover cable. But make sure if it's auto MDX, then you don't need to worry about it. And it's just a category, and that's all. That's a category. That's it. So you know what speed you have, and that's a category 8. All right. That's all. So for today's lecture, and we learned about a lot of things, but in the next class, we will surely tomorrow at early morning, we will learn a lot of different things too. Very different stuff. Right now, today, we just want to go for recap. That's all. Base T meaning and male side and female. And a little bit more into deep termination of cable tomorrow, a little bit. And that's all we got. In the desktop, there is nothing like no. In the desktop, there is nothing like auto MDA. Nothing. In the desktop, no. Only in switches.